Hey chemistry students, so we have been talking about atoms and we've been talking about the different parts of the atoms. We've talked about the protons and the neutrons and the electrons, and now what we're going to do is we're going to stop and we're going to focus on one of those. We're going to focus on the electrons, okay? Understanding something about the electrons is going to help us understand a lot of different things. It's going to help us understand how the periodic table is set up. It's going to help us understand how these atoms behave, how they interact with each other, how they bond with each other, what kinds of compounds they make with each other. So understanding what goes on with these electrons is going to be very important for us going forward in chemistry. And today what we're going to do is we're going to talk about those electrons. We're going to talk about how they sit in an atom in what's called an electron configuration. And so today we're going to talk about electron configurations, and our target is to be able to write the electron configurations for the different elements. So let's go ahead and let's take a look at what that means and how to do that. Okay, so as we talk about atoms, most of us probably look at, we think about atoms and we think about a picture that looks something like this, okay? In this picture here, there's a couple of things about this picture that communicate stuff about atoms really well, but there's also a lot of this picture that does not communicate stuff about atoms very well. There's a lot of inaccurate things about a picture like this. For one, the nucleus of the atom here is enlarged to show us the particles. In reality, the nucleus of an atom is tiny, is minuscule in comparison to the size of the atom, right? The other thing is the way that the electrons are here, okay? Oftentimes, we'll see atoms drawn with these kind of orbits so that the electrons look like they're orbiting around the nucleus. In reality, they don't really kind of look like that. In reality, they look more like this. Okay. In this picture, you can see this is different, right? Okay, in this picture, you don't see those kinds of orbits going around the nucleus. You can see the nucleus is very small in the center, but then you see kind of a fuzzy, cloudy area around that nucleus. And that kind of fuzzy, cloudy area, we call that the electron cloud. Okay, that electron cloud is where the electrons are gonna be, probably, right? Now, that electron cloud, there's some different areas within the electron cloud, okay? That electron cloud, if we kind of clear it up a little bit, it might look something like this. Okay? In this picture here, you can see that there's the nucleus at the center, and then in that electron cloud, you can see there's some different energy levels going out from the middle of the atom, from the nucleus, right? And those energy levels are where we're going to find our electrons. And you can see they're numbered. You see the first one is number 1, and then number 2, and then 3 and 4, and so forth, right? So that's energy level 1, energy level 2, energy level 3, energy level 4. So we can tell where we're going to find the electrons in an atom looking at these energy levels. Now, these energy levels are also further broken up into what are called orbitals. Okay, an orbital is kind of like a sub-level. There's the energy levels, and then there's like a sub-level. It's called an orbital. Okay, we're not going to go too much into what the difference between them is. They're different shapes, is what they are. But there's 4 different kinds of orbitals. One of them is called an s orbital, and then there's a p orbital, a d orbital, and an f orbital. Okay, and each different energy level has one of each, except they don't all have one of each. Okay, the first energy level only has an s orbital. The second energy level has an s orbital and a p orbital. The third energy level has an s, p, and d energy level, and then the ones above that have all 4 energy levels. Right? So we have 4 different kinds of orbitals: s, p, d, and f, and each energy level is going to have the different kinds of orbitals. Let me show you how we talk about this. Okay, so oftentimes when we talk about where electrons are, what we'll do is we'll write the number of the energy level that it's in, what type of orbital it's in, and then how many electrons are in that orbital. Okay, so it'll look something like this. What you see up here, it says 3ds, or I'm sorry, 3d2, right? Okay, now what this is telling us is that first number there, that big number that's in front of the d, that's the energy level we're talking about. So what are we talking about here? We're talking about energy level 3. Okay, and then that letter there tells us which orbital we're talking about. So in the energy level 3, there's an s orbital, there's a p orbital, which one are we talking about? Here we're talking about the d orbital. And then that little number that looks like an exponent is how many electrons are in that orbital. So what this is telling me is that in the d orbital of the third energy level, there are 2 electrons, right? So we can kind of write an address for every electron in an atom, telling which energy level it's in, which orbital it's in, and how many electrons are in that orbital. There's a couple of things we got to keep in mind here. One of the things that we need to know is that each orbital can only hold so many electrons. Okay? An s orbital can hold 2 electrons. A p orbital can hold 6 electrons. A d orbital can hold 10 electrons. And an f orbital can hold 14 electrons. These numbers are going to be important for us to know and remember as we're writing electron configurations here. I'm going to show you how to write out the electron configuration in just a minute. These numbers are going to be important for us to know, for us to have in our mind. So an s can hold 2, a p can hold 6, a d can hold 10, and an f can hold 14 electrons. Okay, another thing we got to keep in mind as we write the electron configuration for an element is that the orbitals in the energy levels of the atom fill in a particular order. Okay, we're going to assign the electrons to the different orbitals. They get assigned in a particular order. Okay, and there's a little graphic here that's going to show you what order they go in. Okay, so just follow the arrows here. Okay, the first orbital that fills up is 1s, energy level 1, s orbital. Okay, follow the arrow. The next one is 2s, energy level 2, the s orbital. Follow the arrow there. The next one that fills up is 2p. It's the p orbital in energy level 2. Follow the arrow down. You can see the next one will be 3s. And as you follow the arrow, it's 3s, and then 3p, 4s, 3d, 4p, 5s, and so forth. You follow the arrow, and you see what order they fill up in. Okay. Now, let's take a look at an electron configuration, and let's write one out for one of the elements. Okay. So now what we're going to do is we're going to write out the electron configuration for one of the elements. Let's write out the electron configuration for zinc. Okay, the first thing we need to do, we need to find zinc up on the periodic table, and we need to see how many electrons are there in an atom of zinc. If I find it over there, we can see that zinc is number 30. It's got 30 electrons. So over here, I'm going to write 30, and I'm going to keep kind of a running total of what I've done over here. Okay, now, the first question I'm going to ask myself as I write the electron configuration, I'm going to look at my little map and I'm going to say, which orbital fills first? And you can see the orbital that fills first is 1s. So I'm going to write 1s. Okay. Now, the question is, how many electrons can go in an s orbital? An s orbital can hold 2 electrons. So I'm going to put 2 electrons in this 1s orbital. Okay, so 1s2 means that there's 2 electrons in that 1s orbital. So now the zinc atom has 30 electrons. I just put 2 of them here. I've got 28 more electrons to deal with. Okay, so now let's look at our map. What is the next orbital that fills? After 1s, follow that arrow. You can see the next orbital is 2s. And I'm just going to keep writing. I'm not going to leave a space. I'm not going to put a comma. I'm not going to do anything like that. Just keep writing. Okay. Now this is also an s orbital. How many electrons can go in an s orbital? We can put 2 electrons in an s orbital. So I'm going to put 2 in that s orbital. Okay. So now I've just put 2 electrons there. I've got 26 more to deal with. Okay. What is the next orbital that fills after 2s? Let's take a look there. You can see it's 2p. 2p. And how many electrons can I put in a p orbital. Take a look there. I can put 6 electrons in a p orbital. So I'm going to put 6 electrons in this one. Okay. Now I've put 6 electrons there. I had 26 to deal with. Now I have 20 left. Okay. After 2p, let's take a look at our little map there and see what's the next orbital that fills. After 2p, you can see it's 3s. I'm going to continue down here because I don't want it to be behind my head. Okay, 3s. Now this is an s orbital, and we can put 2 electrons in an s orbital. And then we have 18 more to deal with. Okay. After 3s, let's follow our map there. We have 3p. 3p. And how many can go in a p orbital? We can put 6. And I have 12 left to deal with. After 3p, follow our map there. The next one is 4s. How many electrons can go in an s orbital? 2. And we have 10 left. Okay. After the 4s orbital, what's the next one? The next one is 3d. Sometimes you get these little weird things where you go up to level 4 and then you go back down to level 3. How many electrons can we put in a d orbital? A d orbital can hold 10. So I'm going to put 10 there. Now I have 10 left to deal with. I just put 10 right there. So I've got all my electrons dealt with. Okay? So the electron configuration for zinc is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. And that tells us where all of the electrons in a zinc atom are. Now sometimes when you write these electron configurations, in fact most of the time when you write these electron configurations, you don't end up with an even amount here at the end. Let's take a look at one that's like that. Okay, now let's take a look at carbon. Let's write the electron configuration for carbon. Okay. Well, first let's go to the periodic table and we'll see how many electrons are in an atom of carbon. And you can see that carbon is number 6. So there are 6 electrons in an atom of carbon. This one's going to be much shorter than that last one that we did. Okay. Now let's write the electron configuration. What's the first orbital that fills? You can see it's 1s. 1s. And how many electrons can go in that s orbital? In an s orbital, we can put 2 electrons. So now I've got 4 left to deal with. After 1s, what's the next orbital that fills? You can see it's 2s. Okay. How many can I put in that s orbital? I can put 2 in there. And now I have 2 left to deal with. Okay. Which orbital fills after 2s? It's 2p. Okay. How many electrons can I put in a p orbital? I can put 6, but I don't have 6 left. I only have 2 left, right? So what I'm going to do is this last orbital will not be full. I'm going to put there what I have left. Even though a p can hold 6, I only have 2. So I'm going to put a 2 there. So the electron configuration for carbon is 1s2, 2s2, 2p2. And a little, if you want a little check to see if you've written it right, add up all of the exponents, right? 2 plus 2 plus 2 should come out to that number of electrons it started with. Okay. Now, oftentimes, most of the time, this last orbital won't be filled. This last orbital won't be filled. The electrons that are here, we call those the valence electrons usually. Usually whatever's in the last energy level, even the whole last energy level, we call those the valence electrons. What those are going to do is they're going to tell us all about how the periodic table is organized. They're going to tell us about how each of these atoms bond with other atoms, what types of compounds they make, the properties of the different elements. These last electrons that are in the last energy level are the important ones. They're called valence electrons. And we're going to learn a lot more about those going forward in the future. Okay, so we've talked there about, energy levels and orbitals and where the electrons are located, and we've looked at how to write an electron configuration for each of the elements there. We talked about what the valence electrons are and what they're going to do for us in the future as we go forward, and we learn more about these and what they're going to help us to understand. So hopefully that helps us to be able to write the electron configurations for elements. So until next time, take it easy.